In which topic we have studied?
Molecules.
Osmosis.
Yes, very good. Osmosis. Okay, so you have studied this in osmosis. They don't allow some components to pass through them. So in semi-permeable. Yes, my voice is not clear.
बीच में आवाज नहीं आ रही थी मैम, अभी आ रही है.
अभी आ रही है. Okay. So in osmosis you have studied. So here also we are going to study 3 different membrane processes which help in filtration process of the water or purification of water. So 3 common types of membrane processes which we are going to study here is reverse osmosis. आपने osmosis पढ़ा है, reverse osmosis पढ़ा है क्या? Yes, students, have you done reverse osmosis?
No, ma'am.
No. So here today we will study reverse osmosis. जो osmosis आपने पढ़ा है उसका उल्टा. Okay, so that will be reverse osmosis. Then we are going to study ultrafiltration also, and the third one is electrodialysis. So these 3 membrane process, that means all these 3 are the filtration process, and all 3 uses membrane for the filtration. So what is membrane? What it is made up of? What are the different types of membrane? So first we will see that what is membrane and what it is made up of, and what are the different types of membrane? What are the pore sizes of membranes? So types means depending upon their pore size, as you said that it is a molecules or the ions to pass through them. Hello.
मैम आपका बीच-बीच में आवाज जा रहा है.
पता नहीं बेटा, जस्ट मिनट. मैं अपने इससे वाईफाई Hello. Hello.
Yes, ma'am.
Now it's clear, beta?
Yes, ma'am.
Okay. So out of these 3, all 3 we have to study in detail along with the diagram. Okay, so diagram and explanation, advantages, disadvantages. So for all these 3 process, we are going to study its diagram, its process, and advantages and disadvantage. So before going to this process, first we want, as I told you, we are going to see what is membrane, what it is made up of, and what are the different types based on their pore size or based on the things they allow to pass through them. Okay, so based on that. So first we will see what is membrane. So membrane is basically, it is a selective barrier. Okay, barrier, that means आपका वहाँ पे एक क्या बोलते हैं उसको हिंदी में, अड़चन. Okay, so it's a barrier between your impurities and the water molecule. Okay, so it will allow some particles, somewhat ions to pass through it, and it will keep some particles on the other side. So a membrane is a selective barrier. That's why here I've written selective. So it is not going to allow all types of impurities to pass through them. Only some impurities will be passed. So it is a selective barrier that permits the separation of certain species in a fluid by combination of sieving and diffusion mechanisms. Do you know what is sieving? Sieving पता है क्या है? What do you mean by sieve? Yes, students. मेरी आवाज आ रही है ना proper?
Yes, ma'am.
Yes, ma'am.
Okay, what do you mean by sieve? Sieve?
Yes.
Don't know, ma'am.
Don't
छन्नी
know?
जैसा कुछ मैम.
Yes, yes, very nice. It is in Hindi it is known as छन्नी. जैसे आपने घर पे देखा होगा, we have tea siever, we have floor siever. आटा छानने का है, चाय छानने का है. So all these are sieve, and you can see that there are small holes or pores into that sieve. So depending upon that pore size, the impurities are going to move in from one side to another side. Okay, so यहाँ पे आपका membrane technology में either by sieving or by diffusion mechanisms, these two are applied, and we are going to use it in different technologies. Membrane. So here membranes can separate particles and molecules. Okay, so क्या क्या separate कर सकता है ये? It can separate small particles like sand, gravels, your leaf, small particles, whatever is there in the water as an impurity, solid particles. Okay, so it is going to separate solid particles and molecules like proteins, carbohydrates, fats. These are heavy molecules, bigger molecules. So these can also be separated over a wide particle range size and the molecular weight. So depending upon the particle size, what is the size of that particle which we want to separate? Depending upon that, we have to select the membrane. So membrane are of different types. So we will study the different types of membrane. So based on the pore size or the particle size, we have to select the membrane. जैसे वाटर मॉलिक्यूल है, अगर वो पास हो रहा है, कैल्शियम क्लोराइड, मैग्नीशियम कार्बोनेट, we have different hardness causing salts also present in the water sample. So all these salts are also can be separated through these membranes. Okay, that is known as ion selective membrane. जैसे हम लोग ने आयन एक्सचेंज प्रोसेस में देखा ना, आयंस, कैटायन एक्सचेंज रेजिन इज गोइंग टू सेपरेट ओनली कैटायंस, anion exchange resin is going to separate only anions. Similarly, here also membranes we get as the ion selective membrane. So that particular membrane will only allow that ions to pass through them, like H plus ions and OH minus ions only, or calcium, magnesium, or monovalent cations, or bivalent cations, trivalent cations. Similarly, anions also. So they are ion selective also. So depending upon the molecular weight of the molecule and particle size, we have to select the membrane. Okay, then only the purpose will be solved. Otherwise, what will happen? हमारा pore size, particle size बहुत छोटा है और हमने membrane big बड़े pores वाले ले लिए. तो in that way, what will happen? All impurities will pass through that. So that should not happen. Our purpose will not be solved. So for that reason, we have to select particular membrane depending upon the particle size and molecular weight of the molecule. Okay. Then these are basically semi-permeable, as you already said, that it's a semi-permeable. Semi means half. It is not going to allow everything to pass through them. They are going to allow some particles or some cations, anions, or some molecules to pass through them. Okay, so semi-permeable membrane uses two mechanisms for removal of impurities. One is your rejection method, other is the sieving method. So what happens in rejection method? Suppose you have like charges, you have two ions of same charge, so they are going to repel each other. Okay, या फिर आपका आयन सेलेक्टिव मेम्ब्रेन, आपका कैटायन सेलेक्टिव मेम्ब्रेन है और आप उसमें से कैटायंस पास कर रहे हो, so that will not happen. They are going to repel each other and they will be left behind. They will not be allowed to pass through it. So they in rejection method, it is going to repel the mineral salts involved in dielectric or molecular forces. And the other is sieving, which we already discussed, that it does not allow particulate matter to pass on a small scale, that is 0.0005 microns. So these the sieve size is of microns. So only tiny organic and gas molecules can pass through this sieve, not the heavy molecules or multivalent ions or your suspended particles. These will not pass. Okay, only small organic compounds or the gaseous molecules or H plus and OH minus ions, these can pass through these small pore size, that is microns, which is in microns, 0.0005 microns. This is the pore size of the sieves which we are going to use. So this is suppose one membrane. I have taken example. to show you that how the molecules pass through these membranes. So suppose this is the green one, this is the membrane, and on this side, on left hand side, we have the feed. So feed means your water sample, hard water sample containing different impurities. So here the small balls which are there blue color, that is the solvent, that is water molecule, and the bigger particles are your solute particles, that is your impurity. कोई भी impurity रहने दो वहां पे. Okay, so they are solute, that is impurity, and solvent is your water. So we have mixture of these impurities and water, and this is the membrane. So these membranes are again the selective membranes, and they are only going to allow the water molecule to pass through them. तो आप यहाँ पे देख रहे हैं molecules, water molecule content is more as compared to the solid particles. Solid particles are only 2, you can see on the right hand side. Okay, so that means what? If your membrane is broken somewhere or it has been distorted, so in that case some impurities can also pass through it, but not all. Okay, so you can see here that maximum is your water molecule. So this membrane is going to allow only the water molecules to pass through them, and whatever comes out from this membrane, that is known as permeate. That means these are the things which are allowed to pass, permeate from the membrane. So we call it as permeate. Okay, so now we will see the different types of membranes. So here I have taken 4 different types of membrane just to show you that what they allow to pass through them. Okay, and at the bottom I have written the impurities. Okay, so here I have shown with the help of symbol also that this brown color bigger particle is the suspended solid particles. Suspended mud, okay, your leaves, flowers, then animal parts, all these can be the suspended particles. Then we have this green color ball which I have shown as macromolecules. Macromolecules क्या हो सकते हैं? Your fats, proteins, okay, these are macromolecules. Then after that we have green color small, again small balls as compared to the macromolecules. They are multivalent ions. Multivalent ions means एक से ज्यादा जिसकी वैलेंसी है वो ions. कौन कौन से? Calcium we have 2+, magnesium 2+, iron 2+, aluminium 3+. Okay, similarly sulfate, carbonate, nitrate, सबका bivalent है. तो multivalent, तो more than one valency. तो उस type की ions है. And then we have purple color small balls that they are monovalent ions. Monovalent ions means either it can be single जिसकी valency है. कौन कौन से? Can you give me some example of monovalent ions, students? Yes. Monovalent ions का example दे सकते हैं आप लोग?
Yeah.
बोलो.
Hydrogen.
Yes, H+ ions. Then negative, positive, both you can say. Yes.
Cl,
Chlorine.
Yes, chloride. Very good. Then
sodium,
Sodium.
sodium. Yes, very good. Then OH- ions.
Yes.
Yes. Okay, so
Yes.
H+, OH- ions, Cl-, so sodium. Yes, bicarbonate ions. Very good. So these are monovalent ions. So जो purple color का आपको balls दिख रहा है, they are monovalent ions. And after that, at the end, you can see blue color small balls, and they are nothing but water molecules. Okay, so first I have taken here 4 types of filter. First filter is microfilter. Okay, microfilter. Second is your ultrafiltration. Third is nanofiltration, and the fourth one is reverse osmosis filtration. So from microfilter, you can see that the solid suspended particles cannot pass through it. They are rejected. Okay, आप देख रहे हो उसका arrow वो वापस आ रहा है, वो उसको pass नहीं हो रहा है. And these arrows, straight arrows, blue color, it shows that it passes through this membrane. So macromolecules, multivalent ions, monovalent ions, and water molecule, they can pass from this was a call, so because of that, my voice may be disconnected. Now it's clear? Is
Yes,
my
ma'am.
voice
Yes, ma'am.
clear? Okay. So you can see here in the diagram that this suspended solid cannot pass through this microfiber filter and it is rejected. Rest all can pass through this microfilter. Then in the second case, ultraviolet, now these substances, they are passed through the ultraviolet filter. So in ultraviolet filter, you can see that ultrafiltration, it's not ultraviolet, it's ultrafiltration. So you can see that here macromolecules are also repelled, it is rejected, and only your multivalent ions, monovalent ions, and water molecules are passing through this ultrafiltration membrane. Okay, then from these three macromolecules and multivalent and multivalent, monovalent, and water molecules, these are passed through the nanofilter. Okay, so now in the nanofilter, you can see that these multivalent ions are also rejected. They are not allowed to pass through it, but only they can allow monovalent and the water molecules to pass through it. Okay, monovalent and water molecule. And then these two are passed through the RO, reverse osmosis membrane. And here you can see that monovalent ions are also rejected and only they are allowing water molecules to pass through it. Okay, so in this way, we have different kinds of filters which are used in different techniques, and you can see that what they can allow to pass through them. Okay, so depending upon their molecular weight, depending upon their pore size, depending upon their ions, that is monovalent, multivalent, or that kind. So depending upon that, it is going to allow. Okay, so this was the type of membrane. So now, excuse me, not that one, that chair. Okay, so here, so you can see that in reverse osmosis nowadays in at home also we are using RO filters, and from that you can see that all your minerals, whether it is good or bad, like some minerals are required for the body, but all minerals, they are getting lost and we are getting only water molecule, and that's why we are facing different problems like knee pain, your legs are paining, hands are paining. Okay, because our body is not getting proper amount of minerals from the water, because at home we are using these kind of filters from which everything is removed. Okay, किसके किसके घर पे रिवर्स आरओ यूज कर रहे हैं? बहुत लोग यूज करते होंगे आरओ, है ना? यस स्टूडेंट्स, करते हैं ना यूज?
Yes, ma'am.
Yes, ma'am.
हाँ, बहुत तो पहले हम लोग वो
No,
कार्बन
ma'am.
फिल्टर, वो कैंडल वाला यूज करते थे, है ना? पहले कैंडल्स यूज होता था, वो कार्बन कैंडल्स, but now the filters which are coming for domestic purpose, that is having multiple techniques, like they have UV and RO, दोनों आता है उसमें साथ में. Okay, UV and RO or UF and RO, all together they are coming. So in that case what happens, all minerals are removed from the water. तो इसलिए कभी कभी लगता है कि जो नॉर्मल पानी आ रहा है उसी को, बट दैट वाटर इज ऑल्सो नॉट गुड बिकॉज दैट इज कंटेनिंग डिफरेंट काइंड्स ऑफ impurities. That is not potable water. The municipal water which we are getting, they have not done some treatment to them, that water. Okay, so that's why we have to use these filters at home. So now we have to start with the first process, that is reverse osmosis. Okay, आप लोग ने osmosis पढ़ा है ना? Tell me what is osmosis. Tell me what is osmosis. What happens in osmosis? Yes, anyone? याद करो, 12 पढ़े ना आप osmosis, थोड़ा जो भी, I don't want exact correct answer.
Teacher, it pass through solvent molecules through semi-permeable membrane from less
Yes.
concentrated solution into more concentrated
Yes.
solution.
Yes, very good. See, आपको तो सब आता है, पता है आपको, then why you you are reluctant to give answers? You have said very correct. It's true that it allows through a semi-permeable membrane, the solvent flows from lower concentration to higher concentration. Okay, so that is your osmosis. So we will see first osmosis before going to reverse osmosis. Just we will revise it. Already you have studied. We will revise that when two solutions of unequal concentration, दो solution है जिसका concentration अलग अलग है, are separated by a semi-permeable membrane, then the solvent flow from the dilute solution, that is low concentration. तो ये आपने already पढ़ा हुआ है. Okay. So this way, this is a tank. In that we have put a semi-permeable membrane at the center and two concentrated solutions, one with lower concentration, one with higher concentration. Just to show the lower concentration and higher concentration, I have taken here some few impurities in the lower concentration and more impurities in the higher concentration. Okay, so from lower concentration to higher concentration, when the solvent flows, that is known as osmosis.
Ma'am, screen is not visible.
Screen is not visible. It's visible, बेटा. आपका network check करो.
दिख रही है मैम.
किसी को नहीं दिख रही है, एक को नहीं दिख रही है.
No, ma'am, it is visible.
बाकी को visible है ना बेटा. Please you check your network. मैंने यहाँ 2 डिवाइस लगाया है, आपको मुझे भी दिख रहा है. दिख रहा है? ओके. दिख रहा है बेटा. आप अपना चेक करिए. अभी दिख रहा है क्या? सबको स्क्रीन दिख रहा है?
Yes, ma'am.
Yes, ma'am.
हेलो. हेलो.
Ma'am.
हाँ, yes. इसमें voice and screen both are clear.
Yes, ma'am.
Okay.
Yes.
So this is osmosis. In osmosis, what happens? As you said, from lower concentration to higher concentration, the flow of liquid takes place. तो यहाँ पे अगर आपका liquid का concentration आपने पहले वाले में देखा, so it was equal level. Okay, level of the water was equal. But in the next case, you can see that when the osmosis has taken place, so that means the water molecule has passed from this lower concentration to higher concentration, and here the level has become low, and on the other side the level has become high. Level rises. Okay, so the difference in the level is the osmotic pressure which is developed. Okay, so this is the osmotic pressure we call the difference in the level. Okay, rise in the level of the water. So this was osmosis, which you have already studied. Now we will see the reverse osmosis. So reverse osmosis is opposite of osmosis basically. So in reverse osmosis, an external pressure slightly higher than the osmotic pressure. अभी आपको बताया ना osmotic pressure क्या है? When normally in osmosis, when the fluid moves from lower concentration to higher concentration, so in that case, when the flow level of the water rises in the other container, so there osmotic pressure is developed. Okay, so here we are going to apply in reverse osmosis, we are going to apply external pressure. वहां पे हमने कोई pressure apply नहीं किया है. The pressure has been exerted. Here we are going to apply the pressure. So in reverse osmosis, an external pressure slightly higher than the osmotic pressure is applied. The solvent flow is reversed from higher concentration to lower concentration. पहले reverse osmosis में क्या हो रहा था? Lower concentration से higher concentration में solvent जा रहा था. अभी यहाँ पे क्या हो रहा है? Solvent is going to flow from higher concentration to lower concentration through a semi-permeable membrane by forcefully. हम लोग यहाँ पे जबरदस्ती external pressure apply कर रहे हैं ताकि आपका पानी higher concentration से lower concentration की तरफ जा सके. Okay. So thus in reverse osmosis, water is separated from its salt and other impurities rather than salts from the water. तो यहाँ पे बेसिकली हम लोग पानी को मूव कर रहे हैं फ्रॉम हायर कंसेंट्रेशन टू लोअर कंसेंट्रेशन. सॉल्वेंट इज मूविंग, नॉट द सॉल्ट इज मूविंग. ओके, सॉल्ट आपका एज इट इज उसी में टैंक में रह जाएगा और सारा आपका सॉल्वेंट जो है वो मूव हो जाएगा. ओके, सो यू कैन सी इन दिस डायग्राम. So basically in reverse osmosis we are applying forcefully we are allowing the water to pass through the membrane and it removes many contaminants. तो जो भी आपका लेफ्ट हैंड साइड में जो भी impurities है, बड़े solid particles, suspended particles और multivalent ions, all that will be left behind and only water molecule is going to pass through that. Okay, so you can see here in the diagram that on the right hand side tank we have water along with the impurities. Okay, and we want to do the reverse osmosis on this, so we are applying the pressure from the top. You can see the arrows, so that is basically we are applying the pressure on that side. So when you apply the pressure, these semi permeable membrane जो बीच में आपका white color का है and that have pores, you can see the pores also, small pores on that surface. So with the help of these pores your water is going to pass through that, not the impurities. Impurities सब यहीं रह जाएगा और आपका water molecule पूरा pass होगा solvent, and you can see the level of rise in the level of the water in the next tank. Okay, yes students, is it clear to you?
Yes, ma'am.
Yes, ma'am.
समझ में आया रिवर्स ऑस्मोसिस कैसा हो रहा है? स्लाइड दिख रही है, एनिमेशन दिख रहा है, स्लाइड दिख रहा है.
Yes.
Okay, so this is the reverse osmosis. So by applying pressure forcefully, we are allowing the water molecule to pass through the semi-permeable membrane and all your water molecule will pass and your impurities will be left behind in the tank. Okay, and on the other side in the tank, your level of water will rise. So this is due to the reverse osmosis.
Means
Okay, तो ये आपका simple diagram है. Yes, बेटा. Yes.
we are filtering again, no?
What?
In simple words, we were filtering it again.
Yes, yes. Again, we can fill the tank with the water and that water can pass through that semi-permeable membrane and your impurities will be left behind. So continuous process can take place. Yes? Yes, your doubt is clear, beta?
Yes, ma'am.
Hello? Okay. So this is a simple diagram where I have shown here, this is the pressure which we are going to apply on the higher concentration side, and this is the lower concentration, that is the fresh water. And when you apply the pressure, impurities will be left here only on the left hand side, only the water molecule will pass. And all your impurities you can take it out from the, yes.
मज्जा आहे तिथे प्लंबिंग वगैरेचं दाखवतात, कटिंग कशी करतात, पाईप वगैरे जॉईन करतात.
फायजा बेटा, फायजा. Okay, so all impurities you can separate it out from this outlet, which is known as concentrate flow. You can remove after a certain period of time when you have softened some liters of 100 liters of water or 1000 liters of water. Then at that time you can clear your tank. You can remove all the impurities from this outlet as a concentrate, and this side whatever you will get the fresh water that you can take from the different outlet. Okay, so this is your reverse osmosis. So what you have to, this diagram I have explained you, the same explanation you have to write if it is asked in exam. So with the help of diagram you have to explain. So what you are going to explain in that process, that suppose we are going to fill the tank with sea water or polluted water is filled in the reverse osmosis cell, and a pressure is applied as I have told you. So how much pressure is applied? Around 200 to 800 psi, PSI. PSI is what? This is the unit of pressure. Okay, so 200 to 800 PSI is applied on it to force the solvent to pass through the semi-permeable membrane. Okay, then this semi-permeable membrane has pores of different size. So this porosity is in such a way that it is going to allow only water molecule to pass through it and not the higher sized ions or molecules. तो ये बड़े particles, बड़े molecules को allow नहीं करेगा, सिर्फ water molecule को allow करेगा pass होने के लिए. Then these membranes are made up of what? Earlier, this membrane was usually consisting of very thin films of cellulose acetate. This cellulose acetate is a natural polymer. Okay, तो ये पहले use होता था fixed on either side of a perforated tube. तो एक common tube लेके दोनों side से उसमें वो एक कपड़ा जैसा रहता था, thin film, and that was supposed to be attached on that tube. Okay, so this was used earlier. Nowadays, we are not only using this cellulose acetate, but instead of that, many polymers are also used, thin films of polymers like polymethyl acrylate and polyamide polymer. These are also used as the membranes. तो पहले हम लोग सिर्फ cellulose acetate use करते थे, but nowadays we are also using polymers. Which polymers? Polymethyl acrylate and polyamide polymer. So these polymers can also be used as the membrane. Okay, so this explanation you have to write in the reverse osmosis. So this is, I have just shown the difference between osmosis and reverse osmosis. So ये आपका osmosis हो रहा है from lower concentration to higher concentration. The red color you can see that is dilute solution. Blue वाला जो है that is membrane, and जो pink orange color दिख रहा है that is the concentrated solution. So in osmosis, it is from slow, that is dilute solution, lower concentration to higher concentration side flow. And in reverse osmosis, you can see it is pressure is applied, and from higher concentration to lower concentration, the flow of water is there. Okay, so this is the difference between the osmosis and reverse osmosis. These are the advantages of reverse osmosis. Okay, क्या advantages है? It removes all ionic as well as non-ionic colloidal solids, higher molecular weight organic matter, all can be removed with the help of RO. जब मैंने आपको filters बताया अलग-अलग, so in through RO you have seen that even not the monovalent ions can pass through. Only water molecules are allowed to pass. So that means all types of ions, whether it is multivalent or monovalent, all ions, non-ionic, colloidal suspended particles, higher molecular weight substances, all can be removed with the help of reverse osmosis. Then it is less expensive than ion exchange. In ion exchange, we have seen that we have to fill those big tanks with the resins, cation exchange resins and anion exchange resins, which are costly. But here we need only one single membrane. Okay, so because of that, polymer membrane we need. So because of that, it becomes less expensive. Then it is economical and efficient also. Okay, आपका पूरी तरह से आपका water soft हो जाता है. Everything is removed from that water sample, so it is very efficient. Economical है क्योंकि less expensive है, and simple to operate and maintain. तो maintenance भी इसका कम है. तो इसमें जो हम लोग membrane use करते हैं उसको पहले हम लोग filters को कैसे हर 6 महीने पे change करते हैं. बारिश है तो 3 months में change करना है. But this reverse osmosis का जो membrane है that has to be replaced once every 2 years. 2 साल में भी आप उसका replacement करोगे तो चलेगा. So it requires the replacement of the membrane once every 2 years. So these are the advantages of reverse osmosis. Okay, any doubt, students?
No, ma'am.
Students, any doubt?
No, ma'am.
Okay.
No, ma'am.
Okay. Now we have to see its applications. और कहाँ पे इसको हम लोग अप्लाई कर सकते हैं? एक तो हम लोग घर पे यूज करते हैं रिवर्स ऑस्मोसिस फिल्टर फॉर डोमेस्टिक पर्पस, फॉर ड्रिंकिंग, कुकिंग एक्सेट्रा। जो पानी उसमें से आता है, वी यूज इट फॉर ड्रिंकिंग, कुकिंग एक्सेट्रा. But there are other applications also of reverse osmosis in industries and all. So we will see some applications. So it is used for desalination of seawater to convert it into potable water. Seawater, आपको पता है, it contains 2.5% of NaCl and 3.5% of other salts. So it is very saline water, salty water. जो आपका sea water है वो बहुत सबसे ज्यादा salty water है. So desalination, that means D means removal, or saline means all salts. So removal of all salts from the sea water can be done to convert it into potable water, that is drinking water. We can do that. Then desalination of industrial wastewater. Industries से जो waste water आता है, sewage water, that can also be used here for reverse osmosis, but after secondary treatment. So what is the first primary treatment, secondary treatment? That we will study in sewage treatment. But just I want to tell you that primary treatment is just sieving. जो भी उसके अंदर suspended particles है, बड़े बड़े impurities है, वो हम लोग को छान देना है. Secondary में क्या है? Suppose we have to add some calculated amount of lime, soda for removal of all hardness causing salts, okay, reactions and all. That is the secondary treatment. So after doing that, we can use that water for reverse osmosis treatment also. अगर आप डायरेक्टली वो इन सी वाटर, इन वेस्ट वाटर को आप अगर इंडस्ट्रियल वेस्ट वाटर को आरओ में डालोगे तो आपका फिल्टर खराब हो जाएगा, मेम्ब्रेन खराब हो जाएगा. क्यों? बिकॉज इट इज हैविंग द पोर साइज ऑफ माइक्रॉन्स, okay, not very big size, so that it can sieve everything. So first we have to do primary treatment, then secondary treatment of industrial wastewater, and then we can use it for reverse osmosis. Then water recovery in dye house effluent, जहाँ dyeing process होता है. Okay, dyeing process कहाँ पे? जहाँ पे आपका कपड़ों का dye होता है, तो वहाँ पे हम क्या use करते हैं? We use the color, that is dye, in water. वाटर में उसको डिसॉल्व करते हैं, एंड इनटू दैट द yarn और योर फैब्रिक इज डिप्ड इनटू इट फॉर डाइंग प्रोसेस. तो उसको डाई करने के बाद वो पानी को क्या करते हैं? आइदर यू हैव टू थ्रो इट आउट, और द अदर वे इज दैट यू कैन रिकवर द वाटर फ्रॉम दैट ऑल्सो. उसमें से डाई अलग हो जाएगा, आपका पानी अलग हो जाएगा विद द हेल्प ऑफ रिवर्स ऑस्मोसिस प्रोसेस. तो वो जो पानी है आपका, जो एफ्लुएंट जो आ रहा है डाई इंडस्ट्री से, दैट यू कैन पास इट थ्रू द रिवर्स ऑस्मोसिस मेम्ब्रेन एंड यू कैन रिमूव द डाई एंड सेपरेट द वाटर, एंड अगेन दैट वाटर कैन बी यूज्ड फॉर द नेक्स्ट प्रोसेस. So then the next is recovery of water for individual use from domestic sewage. जो आपका घर का जो domestic sewage का जो पानी है, that also we can simply by using simple methods we can do the filtration, and we can use it for individual use, like for sanitary use, for gardening purpose. For all that we can use that water. Then we can also control the pollution level with the help of this reverse osmosis. We can know how much pollution is there in that sea water or industrial wastewater. Okay, so these are the applications of reverse. So it is not only the reverse osmosis is not only used at home or for the water filtration at home. It is also used in industries, dye industries, then seawater salination, pollution control methods. For that also we use this RO. Then we have the next, that is the ultrafiltration. Okay, we have I have told you that there are 3 methods. Yes. Yes, beta.
Take tomorrow, ma'am.
Tomorrow?
Yes, ma'am.
Why? Why tomorrow? Tomorrow when we have lecture? Morning we have lecture, but we have to start with the polymers. We have to start with polymers, beta.
Okay, ma'am.
Just I will complete this ultrafiltration. और जो थर्ड वाला है ना आपका इलेक्ट्रोडायलिसिस, दैट आई विल डू टुमारो, बिकॉज दैट रिक्वायर्स 10 to 15 minutes. तो वो करके हम लोग पॉलीमर स्टार्ट कर देंगे. ओके,
पॉलीमर विल बी न्यू चैप्टर और न्यू टॉपिक.
Polymer is a new topic. We will complete water by doing this electrodialysis method.
Okay.
अभी जो मैंने आपको 3 बताया ना, रिवर्स ऑस्मोसिस, अल्ट्राफिल्ट्रेशन एंड इलेक्ट्रोडायलिसिस, ये तीनों होने के बाद वाटर चैप्टर इज कंप्लीट. We have to start with the new chapter, new module, that is polymer. Okay, तो मैं अभी आपका ये अल्ट्राफिल्ट्रेशन खत्म करती हूँ. It will require only 5 to 7 minutes. And tomorrow when we will start with the electrodialysis, that will require 4 to 5 minutes, and then we will continue with the polymer chapter. Okay.
Okay, understand.
Yes. So ultrafiltration, yes, student, please mute yourself. किसका है? मोहम्मद आतिफ.
Yes, ma'am.
I was telling you to unmute. I unmuted you all.
Okay, I'm unmuted.
Mute. Okay. So in ultrafiltration, just now we have seen in reverse osmosis that membrane is your membrane is how the membrane was set in the tank. It was vertical. Okay, and the flow of the water was horizontal. But here in ultrafiltration, it is again going to be reversed. Here in this case, we will see that the membrane is horizontal and the flow of solvent is tangential, that is vertical. Okay, so membrane आपका ऐसा है, horizontal way में membrane है set, and from top you are going water was flowing horizontal. Now here the membrane is horizontal and the water is flowing tangential. मतलब उसके ऊपर से flow हो रहा है. So this is the difference between the your ultrafiltration and the reverse osmosis process. So here you can see in reverse osmosis, this is the membrane, and we are passing tangentially, suppose water, that is your solvent, then this is the salt solution, this is macromolecules. Macromolecules means your that is protein, carbohydrates, fats, all that. Then these are the black color suspended solids like sand, gravels, etc. So you can see that this membrane is not allowing the suspended solids and micromolecules, but they are allowing the salts and the water molecule to pass through them. Okay, तो यहाँ पे membrane आपका horizontal है. This you have to keep it in mind. Membrane is horizontal and the flow of solvent is tangential. Do you know what do you mean by tangent? Maths में पढ़ा है ना आपने tangent?
Yes.
क्या होता है tangent?
Circle
little slanting. It's not directly vertical. It's little slanting. Okay, tangent. Where it is forming a tangent. So here, so you can see that here we, after passing this solvent from the membrane, we are getting two things. This also you have to remember. So this is your membrane, vertical membrane, and you are passing the water through it or any solvent. So this is your feed, and from the membrane, whatever is coming out, that is known as permeate, as already I have told you. So through the membrane, whatever the solvent we are taking, whatever is coming out, that is your permeate, and whatever is left behind on the surface of the membrane, that is your concentrate. जैसे आप लोग घर पे अगर चाय बनाते हो, तो चाय बनाते हैं तो कैसे छन्नी में जब आप छानते हैं तो नीचे आपको जो चाय मिलता है, that is known as permeate, and whatever the tea leaves are there on the sieve left behind, that is your concentrate. Is it clear? Permeate क्या है, concentrate क्या है, समझ में आया? Yes?
Yes, ma'am.
Yes,
हाँ,
ma'am.
तो जो सीव से पास होके आ रहा है, मेम्ब्रेन से पास होके आ रहा है, जैसे चाय आपका नीचे आ रहा है छन्नी से, तो दैट इज परमिएट, और छन्नी के ऊपर जो आपकी चाय पत्ती रह जा रही है वो क्या है, कंसेंट्रेट. Okay, so in the same way, whatever the sample we are going to pass through this membrane, we are going to get two things, that is permeate, जो पास हो जाएगा वो परमिएट, जो पास नहीं होगा दैट विल बी नोन एज कंसंट्रेट. Okay. So what you are going to write in this ultrafiltration, you have to, of course you will draw the diagram and then you will have to write or you have to write the explanation of that. So what you are going to write in explanation that it is a cross flow separation process. आपने यहाँ पे देखा ना फ्लो कैसा है, क्रॉस फ्लो है, मतलब इट इज अ टेंजेंशियल फ्लो, इट इज नॉट डायरेक्ट वर्टिकल फ्लो, it is tangential flow. So cross flow separation process. In this, liquid flows tangentially along the membrane surface producing two streams. कौन कौन सा stream निकलता है उसमें से बताओ? Yes. When the liquid flows tangentially along through the membrane, what are the two things we get? We call it as two streams. What are that? Yes, Atul, you were telling something. Bolo?
Permeate and
Yes.
concentrate.
Yes, permeate and concentrate. Okay, so this is the permeate. Two things we are getting, two streams. One is known as permeate, the stream of liquid that comes through the membrane, that is permeate. And other is concentrate, the other liquid stream which get progressively concentrated in those species removed by the membrane. जो membrane की से निकल गया वो आपका ऊपर रह गया, that is the concentrate. Okay, तो ये दो stream आपका बनता है, permeate and concentrate. So here it uses membrane with pore sizes in the range of 0.1 to 001 micron. तो ultrafiltration के लिए जो हम membrane use करते हैं उसका pore size कितना है? 0.1 to 0.001 micron. Okay, this is the pore size of the membrane used in ultrafiltration. Here also the membrane itself does not act as a collector of ions, molecules or colloids, but acts as a barrier to the species. Okay, तो जो हम लोग उसमें आपका impurities उसमें collect नहीं हो रहा है, it is not going inside this membrane pores, जैसे ion exchange में हो रहा था. In ion exchange, what was happening? H plus ions, calcium magnesium ions was trapped in the resin, and instead of that, from resin, H plus ions was removed into the water. So that was the collector. वहां जो resins था वो सारे cations anions को collect कर रहा था. But here it is not a collector. Okay, it is a barrier. It will just hold these two different layers separately. Permeate को अलग दिखाएगा, concentrate को अलग दिखाएगा. So it is a barrier. It is not a collector. हाँ? कलेक्टर का मतलब क्या हो गया, वो अपने अंदर उसको कलेक्ट कर लेगा, बट दिस मेम्ब्रेन्स आर नॉट कलेक्टर, दिस मेम्ब्रेन्स आर बैरियर. सो अल्ट्राफिल्ट्रेशन रिमूव्स, क्या क्या रिमूव करता है? हाई मॉलिक्यूलर वेट सब्सटेंसेस, कोलाइडल मटेरियल्स, ऑर्गेनिक एंड इनऑर्गेनिक पॉलीमरिक मॉलिक्यूल्स, ऑल दीज विल बी रिमूव्ड विद द हेल्प ऑफ अल्ट्राफिल्ट्रेशन प्रोसेस. So low molecular weight organic and ions such as sodium, calcium, magnesium and sulfates are not removed. So some hardness causing salts cannot be removed with the help of ultrafiltration. That water which will come out from ultrafiltration, that is permeate, that will still contain sodium, calcium, magnesium, sulfates. They cannot be removed with the help of this ultrafiltration. Only we can remove high molecular weight substance, colloidal materials, organic and inorganic polymeric materials. These can be removed. Low molecular weight, जो छोटे छोटे molecular weight के compounds रहेंगे, molecules रहेंगे, वो आपका pass हो जाएगा from the ultrafiltration. क्योंकि आपने देखा उसमें reverse osmosis में हमने कितना use किया था? 0.0001 micron. Here we are using in the range of 0.1 to 0.001 micron. Okay, so that's why this is the difference. So this you have to write in the ultrafiltration. Then we will see industrial application. इसको भी हम लोग कहाँ use कर सकते हैं ultrafiltration को? We can use in paint recovery in automotive industry. Automobile industry है ना, जहाँ पे हम लोग paint होता है. So from there also we can, जहाँ paints आपके mix हो जाते हैं. Okay, तो वो paints को आपको separate करने के लिए वहाँ पे आप automobile industry में we use ultrafiltration, because paint is nothing but organic compounds and low molecular organic compounds, so they can pass through the ultrafiltration membrane. Then fractionation of milk and whey and in protein fractionation, जो जहाँ आपका dairy industry में जहाँ पे छाछ अलग किया जाता है and your butter is removed, so there fractionation of milk and whey, जहाँ पे दूध और छाछ वो सब अलग किया जाता है विद फ्रॉम प्रोटीन, सो दैट इंडस्ट्री वी कैन यूज दिस रिवर्स अल्ट्रा फिल्ट्रेशन. देन रिमूवल ऑफ कोलाइड्स, जो सस्पेंडेड पा, जैसे आपने देखा शुगर सॉल्यूशन पास हो रहा है, सॉल्ट सॉल्यूशन पास हो रहा है, तो दीस सॉल्ट्स आर स्मॉलर मॉलिक्यूल्स, कोलाइड्स, जो आपका इजीली डिसॉल्व हो जाता है पानी में, सो दैट कैन बी रिमूव विद द हेल्प ऑफ this reverse ultra filtration process. And they are also used in many industries like food industry, power industry, pharmaceuticals, biotechnology and semiconductor. तो ये सारे इंडस्ट्रीज में भी आपका अल्ट्रा फिल्ट्रेशन प्रोसेस यूज करते हैं फॉर सेपरेटिंग स्मॉलर मॉलिक्यूलर फ्रॉम द हाई मॉलिक्यूलर वेट कंपाउंड्स. Is it clear, students? Any doubt?
No, ma'am. No, ma'am.
Okay, so we will stop here, and tomorrow is in morning we are going to start with electrodialysis. ये सिर्फ 3-4 स्लाइड्स है, ये कंप्लीट करने के बाद हम लोग पॉलीमर साथ में स्टार्ट करेंगे. ओके, इसके साथ ही ये
Okay,
आपका
ma'am.
सिर्फ छोटा सा टॉपिक बच गया है, इसको करके हम लोग पॉलीमर करेंगे. ओके, just wait for a second. I will take attendance. Yes, I am taking attendance. Okay, civil 1
Present, ma'am.
present. Just I will stop screen share. 2 Faiza.
Present, ma'am.
Faiza, why you were not there yesterday? We took 2 lectures. We have completed so many numericals and all. Why you were not there?
Ma'am, actually, I was
घूमने गए थे?
नहीं,
हाँ,
बैंक का थोड़ा काम था.
बैंक संडे को बंद रहता है.
नहीं,
Okay.
इधर का चालू है.
चालू था. ओके.
हाँ.
सिविल 3 अब्दुल कादिर.
Present, ma'am.
प्रेजेंट. 4 आलिकर
Present, ma'am.
हसीब. प्रेजेंट. 5 अंकित.
Present, ma'am.
प्रेजेंट. 6 प्रेजेंट. ये तो सामने बैठा है आज. 7 अंसारी मोहम्मद अनस. अंसारी मोहम्मद अनस. 6 नॉट देयर. 6 है, सॉरी. 7 इज नॉट देयर. यस, नहीं है. एब्सेंट. ये एब्सेंट है. 8 देशमुख मोहम्मद. ये भी नहीं है. 9 फकी अनस.
Present, ma'am.
प्रेजेंट. 10 फारूकी फरहान. फारूकी फरहान नॉट देयर, एब्सेंट. 11 खान आमिर. एब्सेंट. 12 खान मोहम्मद आतिफ. एब्सेंट. 13 खान मोहम्मद दानिश.
Present, ma'am.
प्रेजेंट. 14 अयान. एब्सेंट. 15 मोहम्मद कैफ. एब्सेंट. 16 अतुल.
Present, ma'am.
प्रेजेंट. 17 प्रकाश.
Present, ma'am.
प्रेजेंट. 18 अबू बकर.
प्रेजेंट मैम.
प्रेजेंट. 19 प्रथम.
Present, ma'am.
प्रेजेंट. 20 ऋषिकेश. एब्सेंट. 21 सुफियान.
Present, ma'am.
प्रेजेंट. 22 अमान.
Present, ma'am.
प्रेजेंट. 23 ताबिश.
Present, ma'am.
प्रेजेंट. ओके, टुमारो विल मीट एट 10 o'clock. बी ऑन टाइम. हाँ, आप लोग बहुत लेट ज्वाइन करते हो. 10 बजे तक सोते हो क्या?